Welcome to this session on systematic storytelling presentation using the taxonomy table. In this journey, we'll explore how storytelling becomes a powerful teaching tool when structured with Bloom's revised taxonomy. This slide introduces the knowledge dimensions. They represent different types of knowledge: factual, conceptual, procedural, and metacognitive. Each of these provides a foundation for how we design systematic stories in learning. Here, we enter Module 3, Competency-Based Training. In this module, we will see how the taxonomy framework helps us identify the right competencies, design learning objectives, and ensure measurable outcomes for our learners. The taxonomy table developed by Anderson and Krathwohl. It combines two dimensions, the types of knowledge and the cognitive processes dimensions. The taxonomy table helps trainers and educators systematically align their stories with learning outcomes. Instead of just telling a story, we can map it to the right knowledge type and cognitive level, making it more impactful and measurable. When applied to storytelling, the table guides us in choosing whether to focus on facts, concepts, procedures, or reflective thinking, and whether the goal is for learners to remember, understand, apply, analyze, evaluate, or create. This ensures that every story has a clear learning purpose. The knowledge dimensions serve as the foundation on which every training program is created. They act like the pillars that support the entire structure of learning. If we fail to clearly define which knowledge dimension is being targeted, whether factual, conceptual, procedural, or metacognitive, then the training will lose its direction. As a result, the program will struggle to achieve the intended outcomes, because the learning activities, assessments, and objectives will not be aligned. That is why we must invest time in researching and analyzing these knowledge dimensions in detail before designing any training. The more concrete the knowledge dimension, the easier it is to explain and apply in practice. On the other hand, the more abstract the knowledge dimension, the more time and process it requires for learners to fully grasp and internalize it. The knowledge dimensions represent both a tool and a job aid for trainers. They help us classify the type of knowledge we are working with, whether factual, conceptual, procedural, or metacognitive. That's why, when we correctly identify the knowledge dimension, it becomes the starting point for designing competency-based training. With this foundation, the learning objectives, materials, and assessments can all be aligned systematically, ensuring that training leads to real competence, not just information transfer. The more concrete a tool is as a job aid to do the job, the easier the training will be to design and implement. On the other hand, the more abstract the knowledge dimension, the more time, reflection, and process are required to translate it into effective training activities. The first step to identify a competency-based training in the knowledge dimensions is factual knowledge. Factual knowledge provides the foundation. Without it, learners will struggle to understand concepts, apply procedures, or develop reflective strategies. In the dimension of factual knowledge, our task is to find the tools that serve as job aids to do the job. The more concrete these tools are, the easier they are to explain and the easier for learners to apply. At this stage, we focus on identifying the terminology, the definitions, and the basic elements that construct the knowledge. Only after these building blocks are established can we confidently move to the next dimension, conceptual knowledge, where learners begin to see connections and relationships between the facts. Here are examples of factual knowledge expressed as tools and job aids in a concrete manner. 1. A handheld metal detector, HMD, where learners must know the terminology, parts, and how it functions. 2. A DSLR camera, where learners need to identify buttons, lenses, and basic elements before mastering photography. 3. A treadmill, where understanding the controls and safety features forms the factual base for using it. 4. A coffee maker, where knowing the components and steps is the first layer of learning. 5. Software project management tools, where learners must first learn the terms, features, and menu elements before applying them in projects. Each of these examples shows that the more concrete the tool, the easier it is to explain and use as a job aid. Once learners master these facts, we can move forward to conceptual knowledge, understanding how these elements connect and work together. Not all factual knowledge is concrete. Some exist in an abstract form, and these are often more challenging to explain. For example, laws, learners must know the specific rules, codes, or regulations even though they cannot be physically touched. Winds, we cannot see the wind directly, but we can identify it through its terminology, classifications, and effects. Radio spectrums, invisible to the eye, yet learners must know the definitions, ranges, and specific elements before applying them. These examples remind us that factual knowledge can range from very concrete, like a physical tool, to abstract, like natural forces or invisible systems. The more abstract the fact, the more time, explanation, and examples are needed for learners to fully understand it. After mastering factual knowledge, the terminology, definitions, and basic elements, the next step in the taxonomy table is conceptual knowledge. Conceptual knowledge focuses on understanding the relationships between the elements of a tool, and the principles or theories of how those elements work together. For example, it is not only about knowing the parts of a tool, but also understanding how those parts interact to perform a function. This shift from factual to conceptual knowledge is critical, because it allows learners to see the bigger picture and make sense of how knowledge connects and operates as a system. And if you still do not fully understand the difference between factual and conceptual knowledge, please pause this video, rewind, and review the explanation again until it becomes clear. Remember, this understanding is essential before moving forward. After factual knowledge, where we identify terminology and elements, and conceptual knowledge, where we understand relationships and principles, the next step is procedural knowledge. Procedural knowledge focuses on how a tool works through standards, step-by-step processes, and sequences. At this level, learners not only know what the parts are and how they connect, but they can also follow a specific procedure to complete a task or operate the tool correctly. This dimension is critical for moving from theory into practice, because it ensures learners are able to apply knowledge in a structured and repeatable way. Are you understand? If not, pause this video, go back, and review again, because mastering this step is essential before moving further. In the taxonomy table, learning develops across 4 knowledge dimensions. Factual knowledge, knowing the terminology, details, and basic elements. Conceptual knowledge, understanding the relationships, categories, and principles. Procedural knowledge, applying step-by-step processes and methods. Next, we will talk about metacognitive in separate video. Each dimension builds on the previous one. That's why it is important to move step by step, ensuring learners fully understand before progressing further. Now, please practice with your own subject matter. Reflect on which knowledge dimension applies most directly to your field. By doing this, you will strengthen your ability to design effective, competency-based training with systematic storytelling presentation. Now that we have explored the knowledge dimensions in detail, the next step is to move into the second part of the taxonomy table, the cognitive process dimensions. If you already feel confident and have mastered the knowledge dimensions, then you are ready to continue watching the next module. In that module, we will explain how the 6 levels of cognitive processes, from remembering to creating, help us structure learning objectives and design more effective training.